I am Maarten De Strycker from BCCA. We're a certification body in Belgium working for the construction sector. And I made this presentation together with Professor Janssens from Ghent University and Peter Wouters from INIVE. And I will share with you my experiences with existing inspection schemes in Belgium. So let me first talk about a bit about inspection schemes, which are also called quality frameworks. So I'll use the two terms in this presentation. Where is an on-site inspection scheme necessary? Well, it's essential in buildings or constructions where the result of the works or the measurement is not visible for the builder or difficult to verify afterwards. So we have these quality frameworks and inspection schemes at BCCA running for post-installation of cavity walls, airtightness tests, reliability checks, the ventilation system in residential applications, and also for sewer renovation where everything is put under the ground after the works. It's very difficult to check what was done, how it was done, and who has done the works. So for these kind of works, we do an on-site inspection during or directly after the works or after the measurements or after the reporting for the ventilation systems, for example. I will not go into detail about the process in airtightness test and ventilation inspection schemes. These are documented in papers that are available in the airbase from AIVC, and we discussed it in previous presentations. So I'll go over to the results of the quality frameworks for airtightness and ventilation. For ventilation, we created a new profession which is the ventilation inspector. So besides the ventilation installer, they're in Flanders now ventilation inspectors. So they're doing specifically inspections on ventilation systems. We created a new profession. There was an evolution in measurement devices. So as you now have to measure airflows, also manufacturers of measuring devices made an evolution in making the work of the ventilation installer, but also the ventilation inspector more easily to give them by giving them specific measurement devices. Most important conclusion is that it is possible to implement and to achieve an effective auditing system. So here you see on the horizontal axis the result of the airtightness test as reported by the airtightness tester, and on the vertical axis the leakage flow as measured by during an audit by an auditor from BCCA. And what you would expect is that these results are on a straight line with a slope of 1, which is the case, apart for some outliers on which we did more checks and a study on why was this result deviating, and finally to resolve these deviations. And you see that it's not always in the right direction, in the same direction. So there is no bias in a direction where the inspection is reporting or the airtightness tester is reporting systematically a lower leakage flow than what is measured during an audit. So we have an effective auditing system in place. So you can have a distribution over all inspectors or all airtightness testers. You can have a good distribution over all types of buildings. You can have a good distribution in speaking about the region. So here you see a map of Flanders. The green dots are all places where a ventilation inspection took place in 2023, and the orange dots are then where we did audits. So we can have a good distribution over the region, and also a good distribution in time. So when we started these quality frameworks, some people were very skeptical, saying that there will be only done ventilation inspections or airtightness tests during the night and during the weekend when you cannot do check whether it's done right or correctly. But you see here about 7% of the measurements or inspections are done during the weekend, and we realize about 5% of our audits also during the weekend. So we have a good distribution in time of our audits we're performing. Specifically, some results of the ventilation quality framework is that in residential systems, the flow hood device is the most popular measurement instrument. But you have to pay attention for some technical challenges on site, because people get very creative, and you have to develop some guidance like what is allowed and what is not allowed. How can you measure in specific situations? And that you have to develop, but this is because this is not yet mentioned in the standards at this moment. And you have to do a broader communication and involve all parties. The latest thing we did was writing an article in a newsletter for kitchen installers to make clear that these kind of valves are very inefficient from the ventilation and indoor air quality point of view, but also very difficult or not possible to be measured by a ventilation inspector. So to make this clear, we also made a specific communication. So you have to involve all parties if you want to install an inspection scheme on ventilation. What are the results? So the quality framework for ventilation started at the 1st of January 2016, and by the end of 2019, we organized a survey, and one of the questions was, to what extent did the quality framework improve the installed ventilation systems in the last 3 years? And the result of these respondents is that they say that 94% of the respondents say that there is an improvement in the quality of the ventilation systems, of which 42% say that there is a significant or better improvement for the ventilation system. So we can achieve good results by installing an inspection scheme on ventilation systems. What are, for me, crucial elements in an inspection scheme? Well, you have to create a management framework. You have to have a dedicated team which has different skills, like technical skills, knowing how is ventilation system designed, how it is maintained, how it is installed, how can ventilation airflow rates be measured? How can you organize such an inspection scheme? Different skills that you have to bring together, and you have to develop clear rules to make it clear for everybody involved in the scheme what is expected during an inspection. You have to do a lot of consultation. You cannot overestimate the amount of consultation you have to do if you install such an inspection scheme. You have working groups, advisory boards, organize a commission for certification or recognition, and give feedback to the authorities if you put it in a legal framework. You have to do a lot of communication, because a lot of parties are confronted with such an inspection scheme. Write newsletters, set up a website, give information sessions to broader public, make clear who is certified and who is not, and what they're certified for, provide documentation, which is included in the communication, follow standardization and international networking, and you have to create compelling boundary conditions. If you leave it on a voluntary base, then nothing will actually happen. You have to find some way to motivate people to use this inspection scheme. You have to provide training, not only to ventilation inspectors, but also to a broader public, like architects, ventilation system designers, manufacturers. You have to put them all into specific training sessions, and you have to qualify persons, and especially when you're trying to measure ventilation airflows, then a practical examination in which people prove that they have the right devices and they know how to use them properly can be very useful. Yeah, we're talking about databases, making results available, consultable. Then you also have a web application, but because you have to make this database accessible, and think about who can access these documents, especially when you're working in a legal framework that authorities can access the documents in the reports. And you have to have organized some kind of surveillance on the reporting, because if you leave it over to the market, well, you will have maybe not reliable results in the database, and you have to organize some on-site checks and also desktop inspection, from which you can learn a lot about how inspections or measurements were done. And last but not least, you have to create a level playing field on every level of the inspection scheme. So if you allow different organizations to organize inspection schemes, then you also set minimum requires to all of these parties that are organizing this. Second part of my presentation is about my experience or our experience with ventilation in non-residential buildings. Before that, I have to say that or explain that there exist already different sets of requirements in Belgium. For new non-residential buildings, there is the EPB reporting, which only contains design values, but there is no mandatory check on site of these ventilation flow rates. For the existing non-residential buildings, there is foreseen that there is a simple visual check if there is something of ventilation available in the building, but there is no real evaluation of the effectiveness of the ventilation system or even foreseen to measure the airflows. Besides this regional regulations, there is also federal regulation on well-being in workplaces. So this is limited really to workplaces. And there's a requirement in terms of minimal airflow rate or maximum increase in CO2 concentrations. And besides that, the Ministry of Health published a federal law on indoor air quality in public spaces. So this is limited to public spaces, which is complementary, for example, to workplaces. And then there we aim at a voluntary labeling of spaces where it is the aim to communicate about the indoor air quality in these spaces based on CO2 or the ventilation rates available in these spaces. So this is regrouping what I said on the previous slide in a scheme. So I'll not go into detail because I'm running out of time. What we see for challenges for inspections in non-residential ventilation systems is you have a lot of different types of ventilation systems. So they might be hybrid, complex systems, or even non-defined, where you have only extraction of polluted air, but it's not clear how there is air provided to the space. You have an interaction with HVAC systems, often in non-residential systems, where you can have questions about the share of fresh air that is distributed in these spaces or in these buildings. You can have complex control systems based on manual interventions, interacting with a clock system and some sensors built in that can collaborate or just distract each other, that the system is maybe not functioning at all anymore. You have a lot of buildings, existing and new buildings, with different levels of ventilations or different requirements historically in these buildings. You have a lot of spaces with different activities inside. For example, the pollutants in a restaurant can be very different from those in a gym, as I will show later on in the presentation. And you have to think about the number of inspectors required to set up such an inspection scheme. So it might be interesting to think about different levels of competence needed depending on the complexity of the ventilation systems inside these buildings. Ghent University did some test events in sport infrastructure. I will not go into detail, just skip to the results, but what was clear is that none of the installations worked as expected by the operator. There is often no balance between supply and extract air. And yeah, we have a lot of problems with maintenance of the ventilation system. So the closed air door dampers or clogged extraction grids or faulty setting in the building management systems. You can also have a lot of questions about ventilation effectiveness. And I just want to go to the recent article that was published by Klaas de Jonge and Arnold Janssens, where they did some monitoring on indoor air quality by measuring PM10 results and PM2.5 concentrations in the indoor air and the CO2 level. And for most of these spaces or situations, the CO2 level is very similar or has the same trend as the PM 2.5 concentration in these rooms, except for 2 is in the gym, where we have high CO2 concentrations, whereas the PM 2.5 concentration is still under control, which might be due to the activity of the human beings in these rooms. And for the restaurants, which is also different, where we have high PM 2.5 concentrations and the CO2 level is under control. So this depends on the activities that are happening in the kitchen of the restaurant, of course. So the conclusions are that an indoor air quality label based just on CO2 level can underestimate the impact of other pollutants. So you should define a range of priority pollutants to really have something about, or to be able to say something about indoor air quality in these spaces. So to conclude, for residential applications, we have a ventilation inspection scheme operational in Flanders for almost 10 years, so we have some experience. It is possible to set up an inspection scheme. There are some prerequisites that I showed in the slides, and you have to keep the pressure on correct reporting if you want reliable results in the database. For the non-residential ventilation systems, I think we can say that indoor air quality is not always bad. There is often some kind of ventilation system present, but there are still some challenges when we have to really certify the indoor air quality or the effectiveness of the ventilation system on the indoor air quality. And by this, I end my presentation and will be happy to answer your questions.